This is Geometry, Unit 3, Lesson 5 on the distance formula. So what we're going to talk about today is a formula to find the distance between any 2 points. So let's take a look at what we have. All right, so I have a triangle graphed here. I have point A is at 1, 4. Point B is at 1, negative 2. And point C is at 5, negative 2. Okay, so what I want to figure out is the length of the segments of the triangle. So I want to find the lengths of AB, BC, and AC. So there are 3 different kinds of lines, so we need to look at what we have to do to find them. All right, so let's take a look at BC. BC is a horizontal segment. Okay, so since that is a horizontal segment, we want to find the distance from B to C. We can just count the boxes. All right, so if I count the boxes here from here, 1, 2, 3, 4. So BC is going to equal 4. All right, now if you want to think of this as the coordinates, the y coordinates are the same. So we would take the difference between the x coordinates. All right, so we go from the point, for BC, we go from the point 1 to the point 5. All right, so that is from 1 to 5 is a change of 4. So that's going to be, technically 1 minus 5 is negative 4, but since distance can't be negative, it's just going to be 4. So that's where that comes from. So BC is just going to be 4. So with a horizontal segment, you can just count. All right, the same thing is true for a vertical segment. AB is a vertical segment. So if we want to find the distance from A to B, from here to here, we just count the box between the points, or since the x coordinates are the same, take the absolute value of the difference in the y coordinates. Okay, so if I go from here, 1, 2, 3, 4, 5, 6. All right, so we know AB is going to be 6. Or you can just say from A to B, the difference is the difference between 4 and negative 2. Minus negative 2. And that's the absolute value of 6, which is going to be 6. Remember, distance is always going to be positive. So if we're looking for the distance, it's got to be the positive distance. So AB and BC we have because they're horizontal and vertical. Okay, now we run into an issue when we look at a diagonal segment. Distance can't be found by counting if it is diagonal. There is no way for that to work. Okay, but if we look at this line right here, this is the hypotenuse of a right triangle. All right, the hypotenuse is the side that is across from the right angle. The right angle is right there because that's a horizontal and vertical line, make a right angle. So if that is the hypotenuse, we can actually use the Pythagorean theorem. All right, the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. And you may see it as a squared plus b squared equals c squared, where c is the hypotenuse. All right, so if we have our right triangle, ABC, that is here, we had A, B, C. We know that AB is a leg, and that was 6. BC is also a leg, that is going to be 4, and then AC, off across the right angle, is the hypotenuse, so that's what we're looking for. So we want to do leg squared plus leg squared equals hypotenuse squared. So that is AB squared plus BC squared equals AC squared. And the hypotenuse always has to be over here. So that's going to be 6 squared plus 4 squared equals AC squared. 36 plus 16 is equal to AC squared. So that means that AC squared is going to equal 52. And so we have to take the square root of both sides. So AC is going to be the square root of 52. All right, we can simplify that if we want to, but the square root of 52 works right now. If you want to simplify it, it's 4 times 13, which would be 2 times the square root of 13. So this is AC is going to be the square root of 52. We're going to leave it as that for right now. All right, so AC is going to be the square root of 52. So we did this by creating a right triangle using the horizontal and vertical as the legs, and this is the hypotenuse. All right, now that is the basis for the distance formula, is the Pythagorean theorem. So let's take a look at the distance formula, what it actually is. All right, the distance formula is x2 minus x1 squared plus y2 minus y1 squared, or delta x squared plus delta y squared. Now you're probably thinking, where did those values come from? All right, so if I'm looking at these 2 points right here, x1 and x2, the change in x would be the horizontal distance between here and here. That would be delta x. The vertical distance would be delta y, it'd be change in y from here to here. So this would be y2 minus y1 right here. All right, so if I take the change in x and the change in y, it creates a right triangle like this. So technically, this formula comes from the Pythagorean theorem. Delta x squared plus delta y squared is equal to d squared, which is the hypotenuse. If you solve this for d, you get this formula. So d is equal to the square root of delta x squared plus delta y squared. All right, so let's find the length of AB in the graph shown. All right, we are going to use either the distance formula or we can use Pythagorean theorem. So what we need to do is figure out the horizontal and the vertical distance. All right, so what I'm going to do is I'm going to draw in my triangle. I'm going to create a right triangle by drawing in the vertical distance and the horizontal distance. All right, now since those are vertical and horizontal, we can put in the right angle right there. All right, now all I have to do is count. 1, 2, 3, 4, 5. And this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so this is delta x because it's the horizontal distance, and this one is going to be delta y. All right, so let's use our formula. We are looking for the length of AB. That is equal to the change in x squared. In this case, it's going to be 12 squared, plus the change in y squared, which is going to be 5 squared. So AB is going to equal 144 plus 25, which is 169. And if you don't believe me, the square root of 169 is 13. Okay, so AB is equal to 13. So that side right here is equal to 13. Okay, now you could also do this with the Pythagorean theorem because we have the 5 and the 12. You could do 5 squared plus 12 squared is equal to AB squared. And you get the same thing. This is going to be 25 plus 144 is AB squared. 169 is equal to AB squared. So take the square root, and AB is equal to 13. So you can do it either way. All right, so all you need to know is the change in y and the change in x. All right, now, if you're given coordinates, you just have to figure out what delta x is and delta y is. All right, so find the distance between 35, 112 and negative 17, 48. All right, so let's think about delta x for a second. We are going from 35 to negative 17. What are we doing from there? We're decreasing. All right, so if you want to do negative 17 minus 35, that gives you 52, negative 52. All right, or 52 is the change. All right, and then the change in y is going to be 48 minus 112, or 112 minus 48. It doesn't matter which way you go. 112 minus 48 is going to be 64. All right, now, it doesn't matter if the change is positive, is negative, because we're going to square it anyway. It's always going to be positive. So it doesn't matter really which way you go like you do with slope. All right, so if we check our formula here, the distance is going to be, the change in x is going to be negative 52 squared, or 52 squared, plus the change in y, which would be 64 squared. Okay, so I can grab my calculator. 52 squared plus 64 squared. And I get 6,800. So D is going to equal the square root of 6,800. And that's, I don't think that's a perfect square, but let's see. Second x squared, 6,800 is about 82.5 approximately. All right, so it's approximately 82.5. Now we rounded it off to figure out the distance, but 6,800 is, square root of 6,800 is the actual distance when you do that. All right, So now the distance formula, find the distance between the points a plus b, and 5a, b minus 2a. All right, so we might want to do y2 minus y1 for this one, x2 minus x1. So for delta x, we're going to use x1, y1, x2, y2. All right, so the change in x is going to be 5a minus a, which is just going to be 4a. And delta y is going to be b minus 2a minus a plus b. Now notice I use parentheses there because I have to carry the minus to the parentheses. So this is actually going to be b minus 2a, and then this distributes minus a minus b. So the difference in y is actually going to be negative 2a minus a, which is negative 3a. All right, so now let's apply the distance formula. The change in x is going to be 4a squared, and the change in y is going to be negative 3a squared. All right, now be very careful when you square this. 4a squared actually means 4a times 4a. So that's going to be 16a squared plus negative 3 times negative 3 is positive 9a squared. So that's going to equal 25a squared. So what's the square root of 25a squared? Well, the square root of 25 is 5, and the square root of a squared is just a. So there we go. All right, so you can do this with variables, or you can do it with actual numbers. All right, we have a couple more here to do. All right, find the length of JK with endpoints J4263 and K negative 37, 63 negative 37. All right, so let's think about delta x and delta y. All right, what's the change in x? We're going from 42 to 42. What's the change in x? It's going to be 0, because 42 minus 42 is 0. Okay, now the change in y, we're going from 63 to negative 37. So what's happening there? We are decreasing from 63 to negative 37, so it's going to be negative 37 minus 63, which is negative 100. All right, so let's apply the formula. The length of JK, the difference between the x's is 0. The difference between the y's is negative 100. We're going to square it. And this is just going to be 100 squared, which is 10,000. And the square root of 10,000 is 100. Okay, so JK is going to be 100. And we just found the length. Okay. All right, so let's try this last one. Find the length of PQ with endpoints 18, negative 29, and 46, 67. All right, so the change in x is going to be 46 minus 18, which is 28. And the change in y, we are going from negative 29 to 67, so it's going to be 67 minus negative 29, which is 96. All right, so to figure out PQ, it will be 28 squared plus 96 squared. All right, so if I go to my calculator, 28 squared plus 96 squared is 10,000 again. So this is the square root of 10,000, which means PQ is going to equal 100. Okay, and for the last one, we want to find the perimeter of the quadrilateral shown at the right. Well, a couple of these sides we can just do by counting. We can look at AD. AD is a vertical line, and the length of AD from counting from here down to here is 7. So we know AD is 7. We also know that the horizontal line AB we can count as well. That is actually going to be 14. So AB is going to equal 14. Take my word for it. All right, now where we have to use the distance formula is on DC and CB because they are not vertical and horizontal lines. So what we have to do on this is create a right triangle right there. And to find CD,